Now, welcome to this class once again. In this class, we want to consider speed, velocity, and acceleration. We have discussed speed and velocity in the previous class. Now, we want to consider acceleration in this class and explain some other concepts in physics. Now, when you talk about acceleration, what do you understand by that word acceleration? Acceleration can be defined as the rate of change of velocity move with time in a specific direction or in a specified direction. The rate of change of velocity move with time in a specified direction. And when you are talking about acceleration can be an increase change or a decrease change in velocity. So when you have it as an increase change in velocity, we call that acceleration. But when you have it as a decrease change in velocity, it is referred to as deceleration, or we call it negative acceleration, or it can simply be referred to as retardation. Just like what we have here, rectilinear acceleration means the rate of change of velocity along a straight line with time. That means when velocity change along a straight line with time, it is referred to as rectilinear acceleration. When the velocity of a body changes, it could be said to be accelerate. That means, or decelerate. Like I said, acceleration is the increasing rate of change of velocity with time, while deceleration is the decreasing rate of change of velocity with time. Deceleration, once again, can be referred to as retardation, or it can be called negative acceleration. Now, having said that, how do you calculate acceleration? Now, you can calculate acceleration or deceleration by considering the change in velocity. When the velocity changes from final velocity, you are subtracting initial velocity from final velocity over change in time. And when the time also changes, so the change in velocity over change in time is referred to as acceleration. Now, if the change is increasing, that means you are having acceleration. And if the change is decreasing, you are having deceleration. Now, in that case, it is also a vector quantity, and it is measured in meter per second square. As you can see, change in velocity is meter per second, and change in time is measured in seconds. So meter per second over seconds give us meter per second square, and it is usually denoted with letter A, small letter A. Now, how will you now represent that? Just like we have it mathematically, we have it that acceleration is equal to change in velocity. Final velocity is normally given as v, while initial velocity is given as u. So that is v minus u over t. So that gives us what we refer to as acceleration. Now, having said that, the next thing we can quickly look at in relation between speed, velocity, and acceleration is when you talk about the graph. So when you are talking about graph in this place, you are going to consider the first one, which is the distance time graph. The distance time graph. Now, when you plot your distance against time, you are plotting a graph of distance against time. Here you are having distance in meter, and you are having time in seconds. So when you plot a graph of distance against time, you are having this as the slope. And the slope of distance time graph, as you can see, that means for us to get the slope of distance time graph, is going to be change in distance over change in time, or change in time. And change in distance over change in time give us what we refer to as speed. So therefore, the slope of distance time graph is to call the speed. So when you determine the slope of a distance time graph, what are we getting in that case? You are getting the speed. Also, we have what we call displacement time graph. Displacement time graph. So when you are plotting your displacement against time, here you are having displacement and you're having your time here. displacement is also measured in meter, and time is measured in seconds. So when you plot the graph of displacement time graph, this is your slope. And just like what we said in the first case, we are having the slope here to be changed in displacement, change in displacement over change in time. Change in time. When you have change in displacement over change in time, and that gives us what we refer to as velocity. So the slope of a displacement time graph gives us what we refer to as a velocity. And also, we can have a constant velocity. That's when we are talking about the velocity time graph. The velocity time graph. Now, how will you talk about the velocity time graph? In the case of velocity time graph, we are having velocity time graph as this format. You can have it as accelerating, we can have it as constant velocity, and we can have it as decelerating. Now, in this case, this is acceleration. And here you have it as constant or uniform velocity, and here you're having it as deceleration. So under a velocity time graph, this is your velocity in meter per seconds, and you're having time here in seconds. So in a velocity time graph, we have acceleration, uniform velocity, and deceleration. That means, what are the parameters that we can derive from a velocity time graph? Now, the first one is, number one, we can talk about acceleration. Acceleration in velocity time graph. We can talk about deceleration in velocity time graph. We can determine total distance. Total distance covered or traveled in velocity time graph. And the last, we can also determine average speed in velocity time graph. So these are the things, these are the parameters that we can determine from a velocity time graph. And like I said earlier on, if you are new to this channel, ensure you subscribe to get more explanation of the concept and the concept of physics in the simplest form. So you can see, when we are having velocity time graph now, these are the parameters that are attached or are related to velocity time graph, and these are the parameters you can deduct for the velocity time graph. Now, this is acceleration, this is uniform velocity, this is deceleration, and here you're having total distance covered. Total distance covered is area under the graph. That is area under the graph. And as you can see here, this is a trapezium. So this is a trapezium to determine the area of this graph. And you are giving your time here, time t1, t2, and so on like that. So this is how we come across, or this is what we explain under the velocity time graph. Now, in our next class, we are going to still discuss more details on this aspect of uniform motion or speed, velocity, and acceleration. Ensure you subscribe to this channel to get more information. Please ensure and make sure that you subscribe, liking the channel also, and press the bell button to get more notification from us when some other videos are uploaded.